All right, so in the last video, we learned about attempts to scientifically look at the sense of self-recognition, including a disorder that helps us understand it better. In this video, we're going to build off of that and talk about a related sense where we'll once again see that studying how it can go wrong helps us understand how it normally works. And we'll also talk about some neuropsychological disorders, and then after that, how we can study the sense in healthy people in the laboratory. So the sense we're going to talk about in this video is the sense, the feeling, the perception that this here is my limb, is my body, or that I am the one undergoing the experience, feeling this sensation, taking the action. It's a sense of mindness towards our limbs and our body parts, our feelings and our thoughts. It's what helps me distinguish myself from other agents or other objects in the world. So it also, it helps me keep track of sensoromotor routines during things like the use of tools so that I know, my brain knows, I can, safely dip my wooden spoon into some boiling soup, but I can't dip my fingers into the boiling soup, right? Some of that is my body and some of it is not my body. The brain keeps track of that so we know what's safe and what's not, where we need to protect our body and where we can use something as a tool or it's just an external object or whatever. And it's not a sense that's unique to humans by any means. So like, for example, this capuchin monkey here is also a tool user like us. In this case, in the wild, they use a big rock as like a hammer to smash a nut on a log that they choose and select properly to use as an anvil. And this monkey's brain can certainly keep track of what is its body and what is an external object like the hammer, the nut, or the rock that it's using. And they're usually great at it, right? Their brain does this automatically. Although working with these little guys early on in grad school, I found that they definitely can slip and smash their fingers under the rock. And believe me, they react the exact same way as any human that's ever hit their fingers with a hammer. Now, normally our brain is so good at this sense of ownership, of mindness, that we don't even think about it. We don't recognize the brain is doing this all the time, constantly behind the scenes. Though sometimes it may briefly come to our attention in unusual circumstances where we might briefly get confused about what is or isn't part of me, like which finger is mine when I look down at my fingers entwined with someone else's. And we can even sometimes deliberately mess with this in a laboratory, maybe to better understand how the brain keeps track of what is me and what is not me. Now, what we're talking about here, it's been called the sense of ownership, or sometimes maybe the sense of bodily ownership, but often just shortened to the sense of ownership. It's a sense that this thing here, whatever I'm looking at or feeling, this thing here is my body or is my limb, that I'm the one undergoing an experience or a sensation or an action. In other words, this thing feels like my hand, or it is my body that is moving right now, or I'm the one experiencing this thought. Someone else isn't having this thought right now, it's me that's having it. That is sense of ownership. It's so simple and basic, you almost don't think of it as something you perceive. But let me tell you, it's pretty noticeable when you stop perceiving that sense of ownership, when you start feeling like your limb is not your limb or your body is not your body anymore. So there's an extreme form, to show you an example of how we can understand the sense of ownership from a disorder of ownership. There's an extreme form of anosognosia. Remember, that's the denial where they don't recognize a disorder or something like, a paralyzed limb after a stroke. Well, there's an extreme form of anosognosia where some patients who are, say, paralyzed on their left side and they deny it or they don't recognize the paralysis, they'll also look at their own paralyzed limb and feel like it's not theirs, that it's not part of their body. In fact, the neurologist Oliver Sacks, he wrote about just such a case study in one of his early popular books, where a patient was so surprised to find a leg in his own bed that didn't belong to him or didn't feel like it belonged to him, that he flung the leg out of his bed. He's like, get out of here, it's not part of me. And in doing so, he fell completely out of the bed because, of course, the leg was attached. It was his own. It just didn't feel that way. It didn't seem that way to him. Normally, for us, our leg just feels like you, right? In an automatic way you don't think about. But patients like this show us that feeling, that perception, is something the brain is actively doing normally all the time. And when it stops doing that, things obviously get weird. Now, don't worry about remembering the specific name of this condition, but if you're curious to read more, this specific condition is called asomatognosia, which I know it's another mouthful of a condition, but once again, it's a little less intimidating if you look at the root words. It's A for lack of, right? And then we've seen soma before. Soma is our root word for body. Like the soma is the cell body in a neuron. And somatosensory means the bodily senses. And then finally, gnosis, we saw before, is the root for knowledge. So asomatognosia is lack of body knowledge. It's lack of recognizing something as part of your body. Again, this most commonly will happen as a side effect, as a sort of an extreme version of anosognosia, where someone has, say, a paralyzed limb or something like that, but doesn't recognize it, and then it doesn't feel like it's part of them, probably because of that paralysis, that lack of ability to move it around or feel anything from it. In an even more bizarre twist, if you ask some of these patients, well then, whose leg is it? Or whose hand is it? Since they don't recognize it as their own, what do they say? Well, since it can't be theirs, the linguistic left hemisphere is going to do its best to confabulate a story. The patient, and again, this isn't the person knowingly or consciously making something up. It's their brain sort of making sense of the data in this way, confabulating things in this way to try and kind of tie it all together into a neat puzzle or a neat explanation. But that's what the person actually experiences. So the patient in our last video where that lady said, "It's my husband's hand, I would know it anywhere," that's an example of this. Or other patients have said things like, obviously it's your hand, doctor. Well, the doctor is holding up the person's own hand. Or that hand, holding up the person's hand, they'll say like, that hand belongs to the patient over there in the hospital bed next to mine. That belongs to a family member. That belongs to whoever else is in the room. Now, this again, don't worry too much about the specific term for this condition unless you're really interested in it, but it's called somatoparaphrenia. From the root word somato, that one's familiar, so that's bodily at the start there. Bodily, and then paraphrenia. And paraphrenia meaning like abnormal or delusional mind, basically. So it's the same phrenia root as in schizophrenia, which has the root word schizo for split and phrenia for mind. Paraphrenia is a term that it used to be used for like elderly dementia patients who had false beliefs, who had delusions. Here we've got sort of a false belief or a delusion, but it's about the body. So it's a somatoparaphrenia. So that's where the term comes from. Now, here's a quote from a research article by Bisiak and colleagues back in the 90s. The doctor asks, "Whose arm is this?" And the patient replies, "It's not mine." "Whose is it then?" the doctor asks. "It's my mother's," says the patient. "How on earth does it happen to be here?" "I don't know," says the patient. "I found it in my bed." "How long has it been there?" asks the doctor. "Since the first day," the patient said. So you get these bizarre conversations with the patient that, like we saw in that previous video, can sometimes seem a little humorous. But it's not that the person is making a joke or knowingly lying. Their brain is just trying to make sense of the fact that they are seeing a body part, but not perceiving it as their body part, not feeling like it's part of them. So their brain then confabulates, tries to make sense of it. What we're seeing in that older lady patient in the last video, that was a case of anosognosia for the paralysis on her left side. She didn't recognize that she was paralyzed, which also then involved asomatognosia with somatoparaphrenia. In other words, asomatognosia with that additional confabulation that we have this term for, right? Bodily confabulation. So, quite a mouthful, but the point is, we're not just failing to recognize a disorder or disability here, like plain old anosognosia, but failing to perceive a sense of ownership for our own body parts, that they are part of us. They don't feel that way. So there's another condition that could also be seen as a problem with the sense of ownership, not a lack of ownership, so much as a disordered form of ownership. It used to be called BIID, for Body Integrity Identity Disorder, but now the literature tends to call it xenomelia. So xenomelia generally presents as someone having a strong and lasting desire to amputate a healthy limb, one that has nothing medically wrong with it as far as we can tell. So it's a dysphoric feeling that your limb doesn't feel like it belongs, doesn't feel like it should be part of you. Consciously, they will recognize, if you ask them, they will recognize it as part of their body. So the sense of ownership isn't completely missing, like in somatoparaphrenia, like we just saw, but the sense of ownership here is distorted. The limb doesn't feel right. It doesn't feel like it belongs. It doesn't feel like a natural or proper part of them. So they want it gone to feel more whole and normal and to feel like their outer body matches the perceived body their brain is experiencing. Now, again, the term, if you're wondering, the term xenomelia, it literally means foreign limb. Like xeno is like in the word xenophobic, where someone fears or hates foreigners. So that might help you remember. It's like foreign or alien and then limb. So most people, it turns out, with xenomelia actually have a particular line where they want it cut. The most common is actually usually above the knee in a specific place. It's actually pretty common across a lot of subjects. And this place where they want it cut is stable over time. So it's not like the person wants part of their leg gone and later they decide they want more of it gone or less of it gone. They're very consistent about the feeling of what part of them doesn't belong, what part of them they really want gone. And there's some evidence that comes from more than just their self-report, their own desire, that suggests there's something physiological or neural going on here. So just for example, if we measure what's called skin conductance response, it's diminished below the line of desired amputation. So below the line where they want it gotten rid of, that part of their body, something in the nerves or the brain representation, the nervous system, seems different. So skin conductance response, basically, it indirectly measures sympathetic nervous system activity. Basically, in this case, their nervous system seems to be treating that part of their body as less like the rest of the body. It's not as reactive. It doesn't, imperceptibly sweat to threat the same way the rest of our body does, that kind of thing. Now, research shows that people with xenomelia are actually 3 times more likely to want a left limb removed than the right, which just has some overlap with what we saw before with left side of the body, right hemisphere of the brain. People have looked at that. Now, furthermore, Magooch and colleagues, including our old friend Ramachandran here, has worked on one of these, showed that if you touch the foot that they want gone, so let's say their left leg, most commonly the left leg is the one they want gone, if you touch the foot on their left leg while scanning their brain, they did it with magnetoencephalography, MEG, but while scanning their brain, you touch the left foot, the brain scan shows a much lowered level of response in the right parietal lobe, which is, of course, the place where we normally would see activity when we touch someone's left leg. You see right parietal activity, right? Well, they found a lowered level of response in these patients in the right parietal lobe when you touch their left foot, even though the response is fine and normal when touching their right foot or for touching the left foot in a control group of patients who don't have xenomelia. And a study in 2018, the one on the right here, actually scanned xenomelia patients and also some control participants in an fMRI while showing photoshopped pictures of the person with their desired amputation. And the brain response that they found to those patients seeing the amputated images was predictive of xenomelia. So basically on the neural level, it seems that the limb is represented differently, and that neural difference is coming out as a perceived experience, a feeling that the limb shouldn't be there, and thus they want it gone. Now, surgeons generally won't remove a working limb, so some people with xenomelia have, in the extreme cases, actually self-damaged the limb, like by putting it in an ice bath until it gets frostbite bad enough that it has to be amputated. And when the limb is amputated, either through something like that or just finding a doctor somewhere, maybe going to a different country where the doctor is willing to do the surgery, many people say their life is way better after the limb is gone. Like their outer body now matches how they feel inside. So xenomelia, again, formerly BIID, has led to some really big, interesting debates in the bioethics literature. So like, what do you think? Should we support bodily changes to match how they internally feel their body is, or how they feel their body should be? And if their dysphoria is fixed by amputation and their life is better afterwards, then one could argue maybe that's the best course of action to help their suffering, right? Yet, if it is something at the level of neural processing of somatosensory information in their brain relating to the sense of ownership, it also raises the question of whether we could help people by using what we know about neuroplasticity to maybe just create a sense of ownership for that limb without needing to remove it. So that brings us to the second half of this video on sense of ownership. Let's move away from disorders of ownership for a minute and look at some laboratory research into how we can manipulate and understand and maybe create a sense of ownership in controlled research conditions. So let's start with this video of some research.
A classical illusion that has been published in 1998 by two Americans, Bodily and Cohen, two American neuroscientists, is the rubber hand illusion. The rubber hand illusion consists in placing, let's say, one's left arm out of sight, out of vision, and placing in front of the eyes of the subject a hand in plastic, a rubber hand, and then the experimenter will stroke, let's say, the index finger of my left hand, and at the same time the left index finger of the rubber hand. And if he does this synchronously for a minute, up to 2 minutes, certain subjects, 2/3 of all subjects, will start experiencing this hand for some moments as if it were belonging to their body. So this is one way, and this is normally investigated by questionnaires. So the subject will be asked a certain number of questions to respond to. And then there is a second measure, which is, in my opinion, even more interesting, because if you then, after these 2 minutes of stroking, will close the eyes of the subject and ask them, well, now point to where your hand would really be, they do not point with eyes closed to the real arm, they will point towards the rubber arm.
I really felt that my hand was transposed and into that false hand that was presented in front of me. The feeling was really an awkward feeling, a very strange feeling of having a false hand belonging to me. We visually see that the hand is false, but we can't separate that from the fact that we actually feel our hand in that place.
By simultaneously stimulating fake rubber hand and the real hand, something that is felt and something that is seen on a hand is integrated. Under normal conditions, when I see something close to a hand and I feel touched at the same position, this is always on my hand, at least I guess in 99% of all cases. So by disintegrating these two types of information, the experimental psychologist interferes with those brain mechanisms that we have through phylogeny, but also through our own development, learned that our brain has learned to fuse together.
So the rubber hand illusion, it's a laboratory way of investigating what normally goes into establishing a sense of ownership for our limbs. And it seems to be a perception that's constructed out of that synchronous overlap, the association or correlation of different sensory systems together, like the bodily senses and the visual and all of that. If we give the same sort of combined, aligned sensory input to the brain for an external object, we may be able to trick the brain into perceiving a sense of ownership for that external object, perceiving the rubber hand as your own hand, as part of your body. In essence, your brain is getting touch information on the back of your real hand. You're literally feeling touch on your real hand, but at the same time, visually, you are seeing that touch happening at a particular part of space. You're seeing it happen there at the rubber hand. And since it aligns so well, right, spatially and temporally, it synchronizes so well with the felt touch, it must be the same touch that you're feeling on your real hand. That must be where the touch is happening in space, is where you're seeing it happen. So in this case, proprioception might disagree, right? It feels your real hand being further out there, farther to the left. But in this case, vision overrules it. Vision wins. We even call it visual capture of proprioception. It's the kind of thing we can normally only study in the laboratory, because in normal day-to-day circumstances, obviously proprioception and vision and touch, they all align accurately in space. The touch happens where we see it happening and where proprioception says it's happening, which is where it's actually happening in normal day-to-day circumstances. But the rubber hand illusion makes such a compelling case for how the brain constructs a sense of ownership, because the evidence of this sense of ownership for the rubber hand, for the external object, it doesn't just come from self-report of the person saying it feels like their hand. As they mentioned in the video, participants will also point to the wrong place. If you ask them where they feel their left hand to be, where they feel that hidden left hand to be, we call this proprioceptive drift. The illusion has overridden their proprioceptive feel of where their hand actually is, and it's drifted toward the location where the rubber hand is. Basically, you can have them use their free hand to move along a little ruler attached to the underside of the table, and tell them with this other free hand to just stop when they feel like they're under their left hand. And they stop closer to the rubber hand than their actual hand. Not only that, though, if you induce the illusion and then threaten the rubber hand, like approaching it with a knife or approaching the rubber hand with a needle, then you find the person shows increased sympathetic nervous system reactivity. Again, measured through the skin conductance response, the SCR that we talked about a minute ago. Basically, they start imperceptibly and automatically sweating a little bit in a way you can't really control. It's a reaction we have no conscious control over. Their brain is reacting like the body is under threat when that needle approaches the piece of rubber that is the rubber hand. But we don't see that effect. We don't see the skin conductance response when threatening the rubber hand if we didn't induce the illusion first. Like in a control condition where you're stroking the real hand and the rubber hand asynchronously in a way that doesn't line up, you're going down the rubber hand's middle finger while going up the real person's index finger or something like that. In that case, no illusion. And when we threaten the rubber hand with a needle or a knife, their body, their brain, their nervous system doesn't react like they are being threatened. Other research has shown that the real hand gets slightly colder after inducing the illusion, like the body is maybe redirecting blood flow. Additionally, in a brain scanner, when you induce the illusion and then threaten the hand, when the person is in the brain scanner, we see that the premotor area in the brain that normally activates to bodily threats, that normally activates for a pulling back your hand action, like when it's near fire or near a spider or near a knife or whatever, that brain area activates if we threaten the rubber hand, but only if we've induced the illusion first. And if you induce the rubber hand illusion and then ask them to reach toward a target, we can actually measure the kinematics of their reaching action, which all can happen out of sight if we cover it up first. And the way they carry out the movement, it turns out they reach as if the rubber hand is where their movement is starting from. Not as if they're moving their hand from the real, true hand position toward the target. They move with movement as if they're going from the rubber hand toward the target. So their brain seems to think their hand actually is there where the rubber hand is. Now, there is a limitation here to this flexibility of ownership. We don't just assign a sense of ownership willy-nilly because visually we see some stroking align with stroking that we're feeling. Because when you do this with wooden stick or a block of wood instead of a rubber hand, it doesn't work nearly as well. And if the rubber hand is aligned wrong, like it's rotated 90 degrees relative to the real limb, then it also doesn't work as well. But even so, we find some pretty impressive flexibility in the way the brain represents the body schema. For example, Ramachandran did a rubber hand study where what he did is put bandages on the middle knuckle of every finger on the person's real hand as they hit it off to the side. And then he put bandages on just a plain tabletop in front of people at roughly the same distance and position as if they were on a hand, and kind of in the same layout as they were on the person's actual hand. Then the researchers did that synchronous stroking on the bandages on the tabletop at the same time and aligned with the bandages on the person's hand. So they're feeling a touch kind of going through that rubbery bandage texture, and they're seeing the brush hitting the bandages, which of course has that same texture, and that did seem to induce some sense of their hand being inside the table or fused with the table. So the rubber hand illusion, it's pretty cool, and it tells us that our sense of bodily ownership is a constructed perception. It comes from how our brain normally integrates information from the different senses in a way that just creates or constructs a sense of me, a sense of me-ness. One quote from an article summarized it this way. The rubber hand illusion suggests that the timing and spatial patterns of our vision and touch signals play an important role in how we come to experience that a limb is part of our own body. So rather than being a perception that comes directly from one system's sensory receptors, this is a higher level perception that comes from how input to those, other sensory systems tends to align together predictably when the brain processes it all together. Basically, think of it this way. The brain needs to keep track of where our arms are at. That's important just to move through the world, not run into things, be able to grab things. The brain needs to track where our limbs are at. It does this through sensory signals from vision, you can see where your hand is, from touch, oh, my hand ran into something, I felt the touch, and through proprioception, right? Oh, this is how extended my muscles are right now. In the illusion, the rubber hand illusion, it's feeling touch happening over on the real hand, but seeing the felt touch happen right in front at the rubber hand. So the brain takes its best guess, and vision basically just overrides and wins out. The perception constructed by the brain is that my hand is here at the rubber hand, so the rubber hand is my hand. It's part of me. At the neural level and the phenomenological level of experience, right, the level of what people perceive, we've got an external object being, at least temporarily, integrated into the body schema. We're tricking the brain into a sense of ownership in the laboratory. Hell, someone's even done a version that made people feel as if they had 3 hands. Like that they had 2 left hands, a sense of ownership over an extra limb, showing just how much flexibility this brain mechanism for ownership has. So the person's real hand doesn't have to be out of sight, but you can make them feel like they have 3 hands. So why stop at hands then? If we're gonna do this, if our brain is that flexible about what's me or not, if it's all just being constructed from sensory input, then why stop at hands? How about establishing a sense of ownership for a whole freaking mannequin body? And one study did that. They had participants put on a head-mounted display, kind of like a VR display, and they fed the display from 2 cameras hooked up eye distance apart on a mannequin. Okay, so it's kind of like getting the view is you're seeing out of a mannequin's eyes, the mannequin's point of view. And they tilted the cameras down as if the mannequin was looking down at its body. Then they stroked the mannequin's torso, so the view is like this, the person, you're told just like tilt your own head down, but they're seeing from the mannequin's perspective. And then they stroke both the participant's torso and the mannequin's torso at the same time, synchronously. So the person is feeling a stroking on their own torso, and they're seeing that same stroking happening here in space on the mannequin. So their brain automatically associates those two because of that strong correlation, because they're synchronized, right? It's got a spatial and a temporal alignment of those sensory signals. So the brain starts to feel like the mannequin body is your body. And not only did these participants say they felt that way, but once again, other measures agreed. For example, they would threaten the mannequin body by sliding a knife into an opening at the bottom of the torso. You can kind of see here. There was like a slot in the mannequin body, and they would threaten it. They would slide a knife in there, and if they had induced the illusion, if they had done the synchronous stroking, that freaked participants out, and their nervous system reacted as if their own body was threatened. But if they had stroked the torsos asynchronously, if they had not induced the illusion, then sliding the knife into the mannequin torso didn't cause those same nervous system reactions. It wasn't like they were treating it like their body. Now, note that this doesn't work for a body-sized rectangular box, so our brain seems to be programmed to have at least some assumptions about basic body shape and what realistically can or can't be part of us, whether that's through evolution of what our body is like or just through decades of experience with our actual human-shaped body. But given this flexibility, why stop at fake bodies? How about a sense of ownership for someone else's body? Can I feel like I'm in your body, so to speak? So in a follow-up experiment, they actually did something similar to the mannequin, but had people basically swap bodies with the experimenter, or at least feel like they had. So They once again put a couple cameras eye distance apart, this time on the experimenter's head. But here they had the experimenter sitting down and the participant just stays standing. And the participant has a head-mounted display, again, getting input from those cameras, so their visual point of view is coming from the sitting position. In this case, the smooth lady arm with the dark clothing would be closest to the point of view, coming out from where the person was looking, while his own hairier male arm in lighter clothing would be visually farthest away and seen as coming toward him from out there. Then the participant and the experimenter would synchronously squeeze hands together, like a little metronome going, counting time off, so that they could synchronously squeeze their hands at the exact same time and see and feel that sensory alignment. And if they did that for a while, if it was synchronized, participants started to feel like the close arm, the visually close arm, was theirs, like the close body was their own, and the far body, which is their actual own body, didn't feel as much like theirs. So the amazing part is that they didn't show the same reaction to a knife threatening their own real body as they did to threats to the experimenter's arm, the one that they were temporarily feeling like was their body. So their brain had kind of flipped and was treating the visually close arm, the one that's close to the point of view, right, the one close to the first person view, as being their body, and then less of a sense of ownership for their actual real body. And all this is despite the participant obviously consciously knowing the situation. There's no delusion or false belief here. It's just a strong sensation, a feeling, a perceived experience of bodily ownership for an external thing, in this case for someone else's body parts. I like this quote from the study. The first time I experienced the body swapping illusion with Valeria, I almost started screaming because it was such a surreal and striking experience to shake hands with myself using a different body. And others have looked at similar things like this in virtual reality and induced similar illusions, building out of rubber hand studies. And this stuff isn't just for fun basic research into understanding the brain. It does have direct applications. So for example, knowing how the brain establishes a bodily sense of ownership, it might be really useful in designing prosthetics that don't get rejected by users. It turns out a majority of prosthetic users, people, amputees, whether they use cosmetic or like a myoelectric kind of prosthetic that they can control, either way, traditionally, users of prosthetics don't feel like the prosthetic is part of them. It's something that kind of you wear out when you need it. It's a tool. It's something they put on to use, but then they take it off later. You get home, you take it off. It's not part of you. It doesn't have that sense of being part of me that comes from a sense of ownership. But research with the rubber hand illusion has suggested we may be able to establish that sense of ownership for prosthetics, for amputees who use prosthetics. And that may be valuable for making better prosthetics or getting them more integrated into the body schema for people. Now, just a side note, but this is, for me, perhaps the weirdest example of how flexible our sense of bodily ownership can be. There was a study in 2010 showing that we can feel touches that are happening out there in the world, out on an external object, as long as we've first tricked the brain into feeling a sense of ownership for it. So to understand how they did this, to understand the 2010 study, you first need to know about something called the cutaneous rabbit illusion. This is just an old school, well-known touch illusion, a tactile illusion. So in the cutaneous rabbit illusion, researchers, what they do is they just produce rapid taps to the wrist and the elbow. So just causing these little tactile touch sensations to the wrist and then the elbow that are timed just right, really close together. If they time them just right, people will actually feel imaginary sensations along their skin between those two areas, connecting those areas. It's described often as if there's like a tiny rabbit moving up the arm. So no tapping is actually happening in the middle of the forearm here. There's no tapping happening anywhere except on the wrist and the elbow. But people experience an illusion of touch movement. They feel movement from one place to the other, as if touch is moving from the wrist up to the elbow. The brain sort of fills in the blanks. Again, it sort of assumes, or again, this happens assuming that the taps on the wrist and the elbow are timed just right. The brain fills in the gaps. Now, a 2006 study used fMRI, used a brain scan to show that those intermediate arm areas, like the places on the forearm where people are saying they feel the touch, those are actually active in S1, in the primary somatosensory cortex, the place that represents touches to those parts of the body from like Merkel discs and stuff. So it's not a selective attention error. It's not a reporting error. The brain seems to be actually representing a fake touch that's there, but we actually perceive the touch. It constructs a perception of touch. It makes people actually feel touch there. So that's the cutaneous rabbit illusion. Again, it's been studied a lot, lots of studies going up to the 2000s, but the interesting one relative to our sense of ownership stuff is this study that came out in 2010. So they showed that you can hop the cutaneous rabbit, hop this illusion out of the body onto an external object, causing people to feel touches out on the object. But this only works if the object is first integrated into that body representation in S1, in our somatosensory cortex, by inducing the rubber hand illusion first. So the brain is flexible enough about how it constructs our body schema that if you trick it into thinking some external object, like a rubber hand or whatever, is part of you, you can then actually feel things out in other parts of space. You can feel bodily sensations in places your body isn't at. I find that kind of weird and fascinating. Now, meanwhile, other people have studied this from a more social psychological perspective. So, for example, in one study, the researcher Manos Sakiris, he digitally altered a picture of the participant's face. So they'd come in, take the participant's face, and then they had a program, an app, to combine that person's face with someone else's face. Like the program could make it be 30% their own face and 70% someone else's face, or vice versa, or any combination, 50-50, 20-80, whatever. So the participant would watch a clip of their face slowly morphing from their face to someone else's face. So it starts 100% their face and slowly morphs until eventually it's totally someone else's face, 0% their face. Or in another condition, in a second condition, they watched it morph from someone else's to their own face. And as they did this in these conditions, in the first condition, they had to press a button, press a key when it starts to look more like the other person, right? So they're starting as themselves. Just press a button when you feel like it looks like an other person, not you. And in the second condition, they would basically, again, it starts as someone else. So they just press a key when it starts to look like yourself. When it starts to look like you, press a key when it gets to that point. Now, what happens here? Well, normally what happens is we're all biased to see the face as other. If it's even a little different from us, our brain clicks into perceiving it as other, even when it's still largely our own features. So in the first condition, they stop the video really early in the morph. They say as soon as it's even a little bit changed, they're like, yeah, this seems like other. This is not me. This is other. But in that second condition, that second video, they stop the video pretty darn late into the morph. They're stopping it when they think it looks like themselves. They wait until pretty far into it, till it's pretty close before they say it's them. So we have a sort of bias to see things as other. But then in this study, the researcher did something cool. He had participants then spend 2 minutes watching a clip of a 50-50 face blend. So 50% self, 50% other morph, the middle ground face. They watched this face on a laptop screen being touched. So they see, you can kind of a little bit see in the image here, there was a little like paintbrush stroking visually the picture here, the 50-50 morph, stroking that at the same time that the participant's actual face was being touched, and in a way that matched. So if and only if the touch was synchronized, if it matched up, then what they found is you start to feel the 50-50 face on the screen as being more you. You feel more of a sense of ownership, like it's your face. So they feel more like less othering, more ownership for the morphed face. And then repeated the initial test. Going back to the initial test, they found that now the participants don't have as much bias to interpret an ambiguous face as being other. They stop the me to other clip, right? This top one, they stop it later than they used to. And the other to me clip, the second condition, they stop earlier than they used to. And it's all through, all through similar channels where aligned input from those sensory channels like touch and vision can be enough for our brain to just automatically construct a perception of ownership, of me-ness. Now, Well, in this video here, in the next video, we're going to see some more examples of plasticity and flexibility in how our brain constructs this sense of our body. And then a final video in this big topic, we'll look at a different subject, the sense of embodiment and why people can feel like they're having an out-of-body experience. I'll end this video with just a silly little dog clip just for fun. This isn't meant to be an actual disorder of ownership. But here's a dog that doesn't seem to recognize its limb as its own.
Okay, we'll do one more sequence and then we'll stop.
So maybe a little bit there, it's the dog's brain is not quite attributing a sense of ownership to its hind limb. All right, see you in the next video.